welcome back to another episode of Hand Tool Rescue. Today we have the 900 Sterling rectifier. Rectifiers, that is also a battery charger, as most rectifiers are. I found this, I don't even remember, years ago. It's just been kind of sitting around waiting for me to get to it. I'm not entirely sure at this point if it works properly. I'm just checking what's live and what isn't live. What I was told when I purchased this was that it was used to charge the batteries in the Model Ts or Model As. And of course, those cars didn't have batteries until nearing the end of their production. So it surely could have been used for that, but I'm not entirely sure. The way this specific tool functions is still a little bit of a mystery to me. I've tried to educate myself as much as possible on the exact mechanics that are going on here, and I'm still not entirely convinced that I have the right answer to my my education at this point, but I will explain what is going on when the parts are kind of all together. The wiring looks horrendous, and I thought it was because somebody had been in here before and made some repairs or some changes. But finding some other photos of these online, which is incredibly difficult to do, you end up seeing that this is how they were actually put together. All this tape, all these weird soldered joints that shouldn't really be soldered together. No ground wire, of course, even though there's a live coil right there for you to touch at any point in time. It's very crude in its finish. I'm not exactly sure why it was left that way and sold that way. Maybe at the time it just really didn't matter. Sterling Manufacturing Company is based out of Cleveland, Ohio, and their factory still exists. It's a car dealership now, but they used to make a lot of voltmeters, obviously rectifiers, a lot of electrical equipment, including radio equipment, and that's probably what they're most known for. So this specific charger could have been used to charge radio batteries at the time. And I'm dating this around 1920s. The technology that is used here, and we're finally getting a good glimpse of that, is something that would be used before vacuum tube diodes were popular to use. As well as there's a similar-ish patent for something that looks like this tool, and it's still a rectifier, and that's from 1910s. So I'm just giving kind of a 10-year grace period. There's also some literature that seems to suggest that's the right era for this tool. So you can see this kind of rectangular box that houses all what should be covered electronics or general electrical business. But you can see the coils near the middle there, and then a long reed through the middle of that coil. And that reed is then connected to an adjustable knob that moves the reed in or not in contact with a carbon rectangular block. So when you first see this, for me, not being an electrical master, I'm just thinking, what in the world is going on with this? I've never seen anything like this before. And I'm fairly sure it's a full wave or half wave vibratory rectifier. And that just means that reed, when it comes in contact with that carbon block, will start to vibrate, and the vibration helps convert the AC voltage to DC, or AC current to DC, or just alternating current to direct current, so that you can charge your battery. And in this case, it's for 6-volt batteries at a maximum of 6 amps. So that's generally how this works. I would love more information if someone is more educated than I am in these kind of things. It's so old, and the few people I have talked to have not really cleared anything up for me because they were somewhat unsure themselves, and they just kind of give me a few options. The amp meter there is accurate. I spent some time off camera trying to make sure that, you know, when it says 6 amps are actually flowing through it. So it's really nice to see something that's essentially 100 years old and that's still calibrated and fairly accurate for what I can see. These end plates were just a nightmare to get off. You know, for you watching, it's 5-10 seconds. This was like 20 minutes to figure out how to get this out without bending or breaking anything. You got to be gentle with these types of things. The core of this, what looks essentially like a dynamo, but this coil is wrapped around these essentially steel rods, and that's the basis of how the electricity is used in this specific tool. These black parts are bakelite, pure bakelite. You can test when things are bakelite by running them under hot water, really, really hot water. They will smell kind of like formaldehyde, since bakelite being an extremely early type of plastic, essentially the first popular type of plastic that was just phenol and formaldehyde mixed together, and then you had some heat, and essentially that's it. A very basic plastic. You can still purchase new bakelite. It's called Garolite off McMaster Carr, if you would like to get some chunks of that for some restoration you're working on. The newer stuff obviously doesn't have asbestos in it. Some of the original bakelite had asbestos, either in sheets or just mixed in to kind of reinforce, much like that glass fiber reinforced plastic you see on modern tools. Here's that carbon block, and obviously there's enough life in it in terms of its length to last 100 years. There's also weird little sheets of what I think are mica. They might just be pure asbestos, and I'm probably going to die, but they seem to be more like mica than anything else. Very odd. I also have not seen that before in anything I've come across, sheets like that for insulation, when they use different things for insulation throughout the whole tool. It just seems weird to choose something differently at that point. I took the ammeter off separately. I just wanted to see that everything was fine and no one was going to die. Once I opened it up, it was actually in worse condition than I thought, but the actual face is in fantastic condition. Other than the broken glass, it ended up being not very bad in terms of its condition at all. I was actually surprised. So that is happy. I was worried that the internals would be just toast, and I would have to either replace it, which would look horrendous, or figure out a way to fix and calibrate something like this, which is well beyond what I'm capable of doing at this point. You got to know the limits before you break things. Doing your standard lead, definitely lead paint on this. So I thought it would be Japanning based on its age, but if it is actually from the 20s. That's also when enamel paints and things like that started to be used over Japan, even especially on Model Ts. So I didn't want to take apart this entire coil. Part of me wants to still take it all apart because I want to see what's going on there. But the rewinding process, along with the general mystery of how this thing works and how it's designed, made me kind of refrain from going that far. It would have been a good tool probably to practice rewinding induction coils on, since I do want to do that for an upcoming restoration where I rewire the entire electrical motor. It would have been great practice, and it's pretty simple since it's just a cylinder. I'm just too afraid to attack something when I don't know enough about how it functions. Also, you can't just throw those in the evaporust. Any one of those coils, essentially can't have moisture on it. When you try to turn it on, it would not be good at all. So you need to kind of refrain from going too far sometimes beyond what you're comfortable with. So I'll just step back and save a rewind for an electric motor for another time. I'll get to it one day. It'll be exciting. You can dunk all the entire coil maybe in evaporust to get all the rust off, but then you would have to rinse it off very thoroughly after and then bake it at a low temperature to make sure all of the moisture is completely gone. I was also concerned that the evaporust might react with something, maybe the paper that they used, that Nomex paper, or maybe the varnish that was used on every single one of the wires. So you really would have to, essentially after soaking it, just rewire everything with properly insulated wire. Not going to do it this time, but to make sure that I don't need to do it and that I'm not wasting my time, I'm going to check continuity. So these two wires should make a beeping noise, meaning they are connected and uninterrupted. And these two should be connected as well electrically. So it seems like the wire connections are in the places they need to be. It's not live when I touch the coil or touch some other part. So that is good. That's a good sign that I can go forward without having to rewire the coil. Here's the worst tool ever made. I hate this thing so much. It is a nightmare tool. It tries to kill me in my sleep, but sometimes it has its uses. I could have done this a million other ways. I just honestly didn't have, like, a hole saw kit would have been probably the best way to do this. But I don't even have one. I could have machined it also on my rotary table. That would have been probably really easy, but this is so easy and does bring a fairly nice result, I would say. It's as round visually as I can get it. I never actually measured how accurately I got it, but it looks great to me. Maybe next time I'll bust out the rotary table. I was kind of concerned that this Bakelite would be so brittle that machining it or using something like a hole saw would crack it. So I literally went with the least invasive method, which was just lightly sawing it on the scroll saw and then sanding away what I needed to. Because this Bakelite is not cheap. Surprisingly, a sheet of plastic can be very expensive. Obviously, I'll need to file in. I can't really drill this half moon shape for another wire to come through. And then I'll need to stamp these A, B, C, and D according to the original. It seemed odd that these are marked like this. It must have been done for assembly purposes, but it's the same on both ends, even though the wiring on both ends is completely different. So I don't know if they just did that for ease of production purposes and just reused the ones that are already stamped, or Maybe I just don't understand the naming system at all. I could be a failure. So when I started wire wheeling the pieces, I realized that a lot of these were actually just pure brass that were then nickel plated, which offends me greatly, obviously, because brass is glorious and how dare you hide it. But I figured I would highlight some areas as brass accents and replace essentially the nickel plating on others, just because I haven't done nickel plating on the channel before, and I thought it would be a good time to explore that. So the solution is incredibly simple. Just dump in a bunch of vinegar, doesn't matter, as long as it'll fit the part you need. Dump in probably way too much salt, but that's the way it is. Let it dissolve, get pure nickel strips that are, you can find them on eBay, nickel anodes or what they're called, or McMaster car. And I hooked up a car battery charger, set it to the lowest amperage possible, and then turned it on and waited, maybe half an hour as the solution is created. So nickel is going into solution here. You can see that by the change in color. It'll slowly go deeper and deeper until it's about this color. Once it's this color, you can add your very clean brass part and turn it on and wait another 5 to 30 minutes, depending on your electrical power. And that's pretty much it. It should come out fairly shiny and looking great. You can make it even shinier, but with some steel wool. But I think this came out fantastically. I did soak it a little bit in hydrochloric acid before dumping it in that solution for plating. That just made sure that the entire surface was completely clean and fresh, ready to accept that plating. You can do that without it. It just produces a better result more consistently. So that rectangular box is nickel plated, but these parts aren't. They were, but now they're not going to be, because I think having that brass in there is glorious and will look really nice. I understand the nickel plating was a corrosion trend and all that back in the day, but how dare you? How dare you cover up the gloriousness? Like, when do you see brass in tools anymore? Come on. You saw those mica sheets again. If they're not mica, I'd like to know. Maybe someone else out there actually knows what they are and why they were used in this specific location and application. Seems like you could have just used some Bakelite, any of the other washers on this tool that seem to block the electrical current otherwise. I was slightly concerned that the tape and the actual fabric on the cloth-covered wires contained asbestos, which is a pretty safe assumption, but I just kept things wet just in case. There's also this screwed-on ring terminal connection that's on all of the ones that I was able to find online. I don't understand why that exists there. Does that wire burn up often that it needs replacing? Why not just make a connection any other way, or just make the wire long enough to go to where you need it to? It just seems so odd. Like a bunch of guys in a garage built this in the 1920s, and here I am thinking it's a real tool. I'm just taking the cloth off of some cloth wire that I have and sticking it on to all of the removed cloth, just because I don't want asbestos in my life right now. So that's the reason I'm doing that. I'm also taking the tape off of these because it's all crusty and hard, and I'll replace it with the exact same type of tape, and that should be fine. It's just kind of a cleanup job. these Bakelite parts here, I didn't show this on camera, but if you soak them in plastic rejuvenator, for car black plastic rejuvenator that you would see at a car store, that brings this back to life. It goes from really brittle to nice and soft and bendy again, and you can kind of get it to do whatever it needs to do. So in this case, I took it off, like the other thin ring shaped Bakelite pieces that I took off. Those I kind of just pressed them on my anvil between two anvils, and that flattened them out and straightened them out, and they look great. Same with these kind of twisted pieces. I'm just soldering with my fancy new soldering setup. I have all the flux. I have all the cleaning stuff. I got appropriately heating power. It is glorious, and I'm really happy about that. You can see the tape. This is actually hard to find, just black cloth tape. I'm surprised. I thought this was like a normal tape that everyone could get at any time. No, I had to special order it. Maybe I'm just a failure not looking in the right places. I could have used tape right there, but I don't know. I just thought this looked a little bit cleaner. Finally, we get to the exciting rebuilding to see if this thing will actually work after I fix up some wiring. The entire time I was 40% sure this would work. That was it. Only because it didn't work at the start, and who knows why? One of those wires in there in this entire rod could be shorting out somewhere. You just have no idea. But with a proper rewiring, I was hoping that this thing could come back to life. We shall see. I replaced a ridiculously unnecessary connection with a similar one because I like to keep things somewhat original, at least visually. And soldering where I probably shouldn't even be soldering. Having a stranded wire to a solid core wire isn't ideal, but how many vibrations is it going to get? Getting these on was a living nightmare. I don't know if maybe the coil position or the plate position in terms of the coil could have been rotated off slightly. I have no idea at all if I put them on in the same orientation as they came off. That seemed to be close based on the wiring positions, but who knows? Just a nightmare to get those on because the amount of force I needed to apply basically required a hammer, and I can't hammer on brand new fancy painted surfaces, even with wood or with plastic. Like the metal's going to bend and the paint might flake off. So it's all just me and my hands violently pushing against it. The second one, the one that's not on right now, was even harder to get on. It was just a nightmare. What can you do? It's 100 years old. They're those thin circular discs I was talking about of Bakelite. They're nice and flattened now and look much better after that solution. This one, I just cut to it being on, but it basically would just barely go on. I don't know what its problem was. I was catching somewhere. It seemed to still be an issue. The one issue that sustained itself throughout the entire restoration is that these plates, when I screwed them to the base, right where the screws are, the kind of feet of the side plates are splayed out a little bit and no longer straight. And that's what I mean by I don't know if I got the orientation correct, because they just won't close. The circle basically won't close around the metal rods enough to have the feet be nice and straight anymore. So I may have had to take them off and turn the the rods a bit, and then put the plates on in a new position. And because it took 900 years to get them on, um, it wasn't worth the risk of damaging the parts just to have that kind of look. And you can kind of see on the right hand, bottom right screw there, how much the feet are off. I can't do anything about it. It would have been not worth it. I may have ended up damaging the rods or something like that. So it's just going to stay like that. Maybe it'll relax over time and I'll tighten the screws down more. Who knows? Anyways, you can see the coil, the copper coil in the middle now, which is attached to a lovely solid brass piece. This entire piece is gorgeous to me. You have copper, you have the lead solder, and then you have the nice brass. It's like just a glorious mix of everything I want in a tool. I'm reapplying the tiniest bit of solder to this coil here. I honestly have no idea what these smaller coils do. They probably regulate some current or voltage. I wish I knew. I honestly wish I knew so you guys could understand, but maybe you understand more than I do. Sometimes you just got to go for things beyond your limits just to learn. And I've definitely learned a lot electrically doing this, but clearly I need to learn a little more to fully understand what's going on here. So that's back together. That should be fine. I have a new piece of glass that I have replaced the broken piece with, and that'll just go on and everything will be fine and look great. You can actually see through the viewing window. Glorious. I'm trying to be as delicate as humanly possible when putting these back together. I don't want to ruin or scratch anything now. But now that the reed is clean, you can kind of see the action where it's going to vibrate back and forth inside of that coil once pressed against the carbon block. It doesn't do anything until it's pressed into the block. And the carbon block will wear out over time. And you would, I guess, adjust that in or out based on the amount of deterioration from the carbon block. Since the electric, the kind of arcing is kind of etching into that, removing some of that carbon. I think it has to have a similar mechanism as a carbon brush on an electric motor. Just nothing's moving at this point, but you'll kind of see what it should do in a moment. This wire attaches to the other end of the ammeter, and then we are pretty much in the zone, the battery charging zone. I was so fearful for my entire life because I decided in my infinite wisdom to basically rewire this without a grounding wire, sticking as original as humanly possible, which I always love to do. So, just turning it on and not dying was kind of my key. I still won't touch this thing when it's on without gloves, even though, I test for a live connection and it's only live where it needs to be. It's just, it's a horrifying death machine. There you can see my cut grounding wire. It's gone forever. Once again, soldering where I could have just used a totally different connection. Maybe just a wire nut might have been fine, but I'll do what they did initially and just stick to it. The only missing part now are the little rubber feet. Now, those are made out of it definitely was rubber, some type of grayish rubber, and it might have been a different color and was worn out over time. I have no idea, but I'm just going to replace it with a full standard black rubber to make it look very nice. And you can see I'm wiring in the other lead that will go to a battery. So here are the ends to it. These little clampy things are awesome and cleaned up very nicely. I'm surprised there wasn't more pitting or anything. And they work just fine. I'm somewhat disappointed that they both have a plus on them. I'm not exactly sure how you were initially supposed to tell which was positive and which was negative. I don't really know, but I left some of the cloth off of the wire so we knew, which was white and which was black in this case, at least to differentiate, so we can get the proper connection when I go to hook this up. And here we are, the moment of truth. It's plugged in. So the coil is still live again, like it was when I initially started. And that makes sense. And then when I hook it up, it actually goes straight to 6 amps, which is what it's supposed to do. I'm probably murdering this battery. And when I engage and disengage that carbon block, it works or doesn't.
Full wave rectifier.
And that's it vibrating. So it actually works, it actually vibrates, it actually charges the battery for all that I can guess. It was definitely an interesting learning experience. And I guess I'll just see you all in the next one if I'm still alive. Later.